So today we're going to look at exponential growth and decay. So let's look at our first question. So we're asked, state whether the given function represents growth or decay. So if we look at our first function, y equals 10 times 1.01 raised to the power x, we'll notice that the value that is raised to the power x is greater than 1. So 1.01 is greater than 1. So this represents growth. Part B, if P of t equals 5 times 0.95 raised to the power t, the value that's raised to the power t is 0.95, which is less than 1, so this represents decay. And our third question, f of x equals 1,000 times 1.05 raised to the power x. Again, the value that is raised to the power x is 1.05, which is greater than 1. So we're looking at growth. Now let's look at the second question. For each function above, so question 1, what is the growth or decay rate? Okay. All right, so let's go back up to the first question. And in part A, we noticed that the value that was raised to the power x was 1.01. So this is the value that is our growth rate. So our growth rate, and it's a growth rate because it represents growth, equals 1.01. In part B, the value that is raised to the power t is 0.95, which is less than 1. So we determined that this represented decay. So the decay rate equals 0.95. Finally, in part C, the value that was raised to the power x is 1.05 greater than 1. It represents, this function represents growth, so our growth rate equals 1.05. All right, so now let's look at our final question. For each function number 1, what is the initial value? So initial value implies that this is the value that we start at, or when our independent variable equals 0. So again, let's go back up to the first question and let's have a look. So in this case, our independent variables x. So when x equals 0, y equals 10, because anything raised to the power 0 is just 1. So in part B, when t equals 0, so p of 0, what do we get? We get 5. And finally, in part C, f at 0 is 1,000. So these are our initial values. And number 4, we got one more question. What is the half-life for the decay functions or function in number 1? So half-life. So what does half-life imply? This implies that whatever we started with initially, we end up with half of it, and we'd have to determine at what time we end up with half of what we started with. So let's go back up to question 1 and see which function represents decay. Okay, so it looks like the second function. P of t equals 5 times 0.95 raised to the power t. So let's go back down and write that function down. Let's see if we can figure out the half-life. All right, so P of t equals 5 times 0.95 raised to the power t. Remember, our initial value or amount was 5. So we're looking for the half-life. So we're looking for the time when our P of t equals half of 5. So 5 over 2 equals 5 raised to the power 5 times 0.95 raised to the power t, and we need to find t. So find t. Okay, so let's do this. So we can divide both sides by 5. We end up with 1/2 equals 0.95 raised to the power t. So now, what should we do? I think we should use logarithms on both sides. Then we can use a property. We'll continue up here. We use the property of logarithms to bring our t down. So on the left-hand side, we have log of 1/2 equals t times log of 0.95. And then we just solve for t. So t equals log of 1/2, 1/2 divided by log of 0.95. So now we can punch that into our calculator and we have our time. So let's see if I can do that very quickly. Let's see, log, good, divided by log, and we get t equals 13, approximately 13.913. So the half-life of our decay function is t equals 13.513. Good, so that brings us to the end. If you have any questions, give us a shout at info@raisemymarks.com or at the following numbers. And thank you for watching.